Alright, so this video is going to be on graphing tangent functions, and it's the second one of two. And so if you haven't watched the first one on tangent functions, go check it out on my YouTube channel. But watch the first one and then come to this one, because this one's going to do a little bit more transformations such as period changes and phase shifts. So period change means that the tangent period could change from pi to something else, and phase shifts means that we could shift the graph left and right. So let's just remind ourselves what a tangent function looks like, and I will do my best to kind of help you out to understand where we're going to head today. Alright, so let's just call this negative pi halves, pi fourths, negative pi fourths, negative or positive pi fourths, and pi halves. Okay? And we've got ourselves our asymptotes. And then the tangent function, remember, has a point in the middle. And then let's say our notches go by 1, okay? Or by halves. And so then they'd go up 1, and just kidding, that's cotangent. Up 1 to the right, down 1 to the left, and you would have your graph looking like this. Okay, so, right, that's a one period of a normal tangent function. It's pi. So what happens if you have like y equals, right, what happens if you have y equals tangent of 2x? So that's going to be, right, a period change. And so the period's normally pi. We're going to divide it by 2. And so the period is going to be, the new period would be pi halves. So what does that mean, right? So that means that from the start to the end, instead of covering a distance of pi, we're only going to cover a distance of pi halves. But is it going to start at negative pi halves and then go to 0? Or is it going to start at pi halves and go to 0? Like, which way is it going to be? Well, remember, this is really like a horizontal shrink. And so since it's a horizontal shrink by a factor of 1/2, then what you're doing is you're essentially moving everything in towards the origin. So you're squeezing it in closer to the origin. So what's going to happen is it's actually going to start at negative pi fourths and only go to pi fourths. So you would actually see this, and I'll do it in kind of blue. So a period change for tangent is different because it really does utilize that idea of the horizontal stretch or shrink. And so you'll still have a point in the middle, but then this would be up 1, down 1, and so now your new graph would look like that. If it gets longer, then both asymptotes would go out, and so it kind of looks like that. So how could you figure out that it was going to start at negative pi fourths? And I'll talk about that in this video. But what I tell students is I say, take what's inside 2x and set it equal to the original asymptote. So the original asymptote is over here at negative pi halves. That's where it normally would have started. And then I solve for it. So multiply by 1/2. And then I can say x equals negative pi fourths. So then I can find out where it's going to start without having to like think about the horizontal stretch and shrink. Not that it's a bad idea to think about what the graph is doing from its transformations, but sometimes it's a little hard to find where it's going to start, because then I could just add the period to find out where it's going to end. And so I would just add pi halves instead of pi, and that would get me there. We still do the domain and range the same. And then when you incorporate phase shifts, shifting things left and right, I still do this kind of thing. I set it equal to negative pi halves so that I can find out where it's going to start, and then I just add the period. I don't try to actually perform the phase shift like I would do with sine and cosine and cotangent. Okay, so here we go. Once again, D is your vertical shift, right? A is considered your amplitude, but we don't have amplitude in tangent and cotangent functions, so it would really be just your horizontal, or excuse me, your vertical stretch or shrink. And then in this video we're going to talk about B, and so that's going to be our period change. And so in order to figure out the period, we're going to do pi, because that's the original period of tangent, and divide it by B. Then from there, C, right, make sure it's factored on the inside. Notice the B is on the outside of those parentheses, factored on the inside, and then that would be your phase shift. So the one thing I want to say is that in sine, cosine, right, sine, cosine, cotangent, and I'll even write it in this video, cosecant and secant graphs. If you want to figure out where the first period would start, in all 5 of these, the first period would start at the phase shift. That's where it's going to start. And then you add the period to go. But in tangent, it's not going to start at the phase shift. So we've got to figure out where it starts by doing a little bit of algebra. Okay? So here we go. We're going to break it down as always. Right? We're going to break the problem down so that we can see all our critical pieces. So our A value is 2. Our period, right, we're looking at the B value. So I'm going to do pi divided by B. So pi divided by 2. That's our period. Our vertical shift is up 1. And our phase shift, or horizontal shift, is going to be needed to we need to factor first. So take out the 2, and then that'd be x plus pi halves. And if you want, you could distribute it back in your own mind to see that it would be the same thing as there. So 2 and then parentheses x plus pi halves. So we're going left pi halves. Okay? And that's not going to be my starting point, because once again, it's not starting at 0. Right? In essence, tangent has a point at 0. That's getting shifted left pi halves, but not the starting value. Okay? So we need to figure out where we're going to start, because this 2 right here means that you have this guy right there, means you have a horizontal shrink by a factor of 1/2, and you have a shift, and so you have to do both. Well, rather than thinking about both, I encourage people to just take what's on the inside, 2x plus pi, that's what's on the inside of tangent, and set it equal to the first starting point, which is negative pi halves. Then we're just going to use some algebra to actually solve. So I'm going to subtract pi. So that'll be 2x equals negative 3 pi halves. Then I'm going to multiply by 1/2. X equals negative 3 pi fourths. Okay, so I'm going to start at negative 3 pi fourths, and I will end, if I add the period, which is pi halves, I will end at negative pi fourths. And so I can figure out what's in the middle. That would be pi halves. And my notches, I believe, should be going by eighths, because if we take our period and multiply it by 1/4, that'll tell us what our notches are going by. So that'd be pi eighths. So this is negative pi halves. Pi eighths, so pi halves would be negative 4/8, right? So then this would be negative 3/8 as I move closer to 0, and this would be negative 5/8 as I move away from 0. If you want to make your second period, you could kind of figure out where that would end. I think it would end at pi fourths. And so then I would have one at 0, negative pi eighths, and pi eighths. So I'm going to make my notches go by pi eighths. That seems like a really good idea by me. And so that's 1/8, that's 2/8 or a fourth, negative 1/8, negative 2/8, negative 3/8, negative 4/8, negative 5/8, negative 6/8. That's where we're going, because negative 6/8 is negative 3 pi fourths, and negative 5 pi eighths, and negative pi halves, 3 pi eighths, negative pi fourths, and negative pi eighths. Alright, hopefully that made sense, right? You've been doing that kind of idea with sine, cosine, tangent, and cotangent before this. But just to recap, really important that we recognize that you take a look, and while it looks like it's shifted left pi halves, which it is, it's not going to start at negative pi halves, right? Notice our starting point is at negative 3 pi fourths. And so that's where my first asymptote is going to go. And then my second asymptote is going to go at the ending point there, negative pi fourths. And then positive pi fourths for another period. Okay, we've got our vertical shift, which is 1, so I'm going to draw that in as well. And then the way to graph tangent is to plot it in the middle and then go up the quote-unquote amplitude, down the amplitude. And then when we're doing the domain, since the domain is not all real numbers, we need to pick an asymptote to describe, right, all the asymptotes. So I'm going to pick, say, positive pi fourths, and then we're going to add the period times n. So the period is pi halves times n, which is any integer. And so then we're going to say x can't equal those things. Pick any asymptote you want. You could have said negative pi fourths. You could have said negative 3 pi fourths plus pi halves n. I just went with the positive one. And then the range would be all real numbers. Right. All right. If you want, you can hit pause and give it a shot on your own. I'm just going to do one more example, and hopefully it all makes sense, and you can be on your way to graphing tangent functions no matter what. So feel free to hit pause, give it a shot, and then watch this back, or just watch this and kind of follow along with me. A would be 1, but I'm going to tell myself to reflect it. Then the period, right, we're looking at the b value, so what is pi divided by pi? We would say that's 1, so the period is just going to be 1. Then the next one, we'll do vertical shift, up 2, and phase shift. Right? The phase shift is going to be, well, let's take pi out, and then that'd be x plus 2, so it's going to be left 2. All right? So we're going to take our inside, pi x, right? Pi x plus 2 pi, and I'm going to set it equal to my original asymptote, negative pi halves. I'm going to subtract 2 pi. That's going to be pi x equals, right? Pi x equals negative 5 pi halves. And then you can multiply by 1 over pi. Leaves you with x equals negative 5 halves. So your first asymptote is going to be at negative 5 halves. And to figure out what your axis is, you can make a little quick sketch over here. Right, so we're going to be at negative 5 halves, and the period is 1, so I'm going to add 1 to negative 5 halves, which would be negative 3 halves. And to figure out our notches, what they're going by, right, they would be going by 1/4, because 1 times 1/4 would be 1/4. So this is going to be negative 2. This would be, so that's what, 8/4. So then this will be negative 7/4. No pi involved, and then negative 9/4. And there we have it. So my notches are going by quarters. So I think I could fit it in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 quarters. So that would be negative 5 halves. negative 9/4, negative 2, negative 7/4, negative 3/2, negative 5/4, negative 1, negative 3/4, right? And then negative 1/2 is probably where it'll go to. Okay, all right, so got my asymptote, first one here at negative 5/2. Next one's at negative 3/2. Oops, that's wrong. Negative 3/2. And then I guess negative 1/2 would be the last one. Okay, and then we could keep going if you wanted. Positive 1/2, 3/2, things like that. All right, we're up to, there's my vertical shift, and tangent, put a point in the middle. Normally tangent will go up to the right and down to the left, but since it's reflected, we'll go up to the left and down to the right, the quote-unquote amplitude. And there's our graphs. And we're going to talk domain, so we're going to pick an asymptote. So I'll say x equals negative 1/2 plus the period times n. So the period's 1, so just plus 1n. And the range is all real numbers. Okay, and that's that on tangent functions. You should be pretty good. All right, if you need help, let me know. All right, talk to you later.